All right, welcome to the review for your QuadFun test. Remember, we learned this material first semester, and we're being tested over it this next Wednesday. So as we work through it, make sure you're copying down everything I'm copying it down, everything that I'm writing down, as well as be sure to go online and use the Quizizz code your teacher provided to make sure you can check all of your answers and that you get credit for it being correct. All right, identify the vertex and whether the graph opens up or down. Okay. Personally, I can look at this and see the transformations, and I can pull the vertex from vertex form. But guys, this is an equation. Anytime they give you an equation, plug it in your calculator. So I'm going to go y equals, and I'm going to type in negative 1/4, parentheses x minus 1 squared plus 4. So you don't even have to know your transformations because the equation was given to you. So if I look at the graph, I can see here that it opens down. The arrows would be pointing down. So it's not this one and it's not this one. And the vertex looks like it'd be about right here, which is at 1/4, not negative 1/4. Okay, so even if you didn't have a calculator, how you do this is you pull out your h and your k. So your h and your k is 1, 4. Remember, inside the parentheses is the opposite of what you think. So not minus 1, positive 1, and the k value is the 4. This negative out front is what reflects it. So if it's reflected, it's going to open down compared to the parent function. So it's going to be opening down, vertex is at 1/4. What are the zeros? Zeros, we've got the acronym ROCKS. Roots, zeros, x-intercepts. So we're looking for the x-intercepts. There's one here at 0, and there's one here at 4. So x equals 0 and negative 4. Nope, x equals 0 and 4. All right, determine if the table is linear, quadratic, or other. So I'm going to look at this, and I'm going to look for the change. So to 0 to 5 is plus 5. 5 to 8 is plus 3. 8 to 9 is plus 1. 9 to 8, minus 1. 8 to 5, minus 3, minus 5. Okay, so it's obviously not linear. So I can get rid of those because this first change is not constant. So let's look at the second change. To get from positive 5 to positive 3, it's minus 2, minus 2, minus 2, minus 2, minus 2. So this second change is what's constant. So it is quadratic because it has a constant second change or first change. Second. What is the symmetric pair to the point 1, 2? Okay, well, let's look for some pairs. That's the only pair I see. So if 0 goes with 0, 2 goes with 2. And 1, 2, 3, the next number would be 4. So the pair to 1, 2 is 4, 2. Guys, I could see that negative 1, 2 is not even a point. 2, 1 is not a point. 0, 2 is not a point. So really, it had to be that one. All right, determine if it's linear, quadratic, or other. So we're finding the changes again. 14 to 10 is minus 4, minus 4, minus 4, minus 4, minus 4, minus 4. So all of those are constant, so it's got to be linear because the first change, not the second change, is constant. First change. Find the range. So we're talking robot. Range is bottom to top. So the bottom of this is down here at negative 5. So we can get rid of this one, get rid of this one. And look, it's an open circle. Open circle means no line. So I want this one, which doesn't have a line. And that already gave us our answer. Which statement about the quadratic functions below is false? I've got equations. I'm going to plug them in my calculator. So I'm going to type in 3x squared plus 2. negative 1/4 x squared plus 7, x squared minus 5. All right, the vertex of g of x is higher than the vertices of the other two functions. So it's asking which one is false, so not true. So let's see. So g of x is this one right here. Is that higher than the other two vertices? Yes, it is. So this one is true. All right, they all have different zeros. Zeros mean x-intercept. So there's one, there's one. There's one, there's one, and this one doesn't even have any zeros. So yes, they are all different, so that's true. The graphs of these functions have the same axis of symmetry. So the line that cuts it in half, this line would cut this one in half, this line would cut this one in half, and it cuts all three of them in half. So they all have the same axis of symmetry. Two of these functions have a maximum point. This right here is a minimum, this is a minimum, this is a maximum. So this is false. Two have minimums. So that is your answer. That one is not true. Guys, you got to be careful and see which one is false. That's what you're looking for. How does the graph m of x equals negative 3x squared plus 2 compared to the parent function? Well, you got to know what the parent function is. Y equals x squared. That's one of your vocab cards. So I'm going to put the parent function in here, y equals x squared, and then I'm going to put negative 3x squared plus 2. And I'm going to see how it changed. So there's the original, there's my new one. The graph has the same x-intercepts. This one crosses at 0, 0. This one does not, so that's false. The vertex is the same. This one's at 0, 0. This one looks like it's at 0, 2, so that's false. It opens the same direction. This one opens up, this one opens down. That's false. Has different x-intercepts. Okay, so one of those had to be the answer. So yes, it has different x-intercepts. Ooh, that's hard to read. Okay, the graph of f of x equals x squared plus 2x minus 3 is shown on the grid. What are the zeros? Oh, so it's just asking for zeros. So right here at negative 3, so it could be this one or this one, and there's another one right here at 1. So the answer is C. Remember, zeros, we've got rocks. Roots, zeros, x-intercepts, all mean the same thing. Given f of x equals 2x squared plus 5x minus 17, find f of negative 1. Anytime they give you a function, what did I say to do? Plug it in the calculator. 2x squared plus 5x minus 17. Okay, this negative 1 is inside the parentheses. If it's inside, it is your x value. So you're looking for where x is negative 1. So second graph, x is negative 1, matches up with negative 20. If you didn't have a calculator and you wanted to do it by hand, you could take this equation and instead of x, put negative 1. So 2 times negative 1 squared plus 5 times negative 1 minus 17. So negative 1 squared is equal to positive 1. So 2 times 1 is 2. 5 times negative 1 is equal to negative 5. So now if I combine those, 2 minus 5 is negative 3. Negative 3 minus 17 is a negative 20. Same answer. All right, which best describes the height of the football at 2 seconds? So here's 2 seconds. So I'm going to go ahead and just kind of sketch in my trend line. Okay, so at 2 seconds, follow it up. It's about right here, which is a little over 20. That one is a little over 20. That's it. That's all you got to do. Make sure you're paying attention to whether it's giving you seconds or it's giving you the feet and asking for the other side. Which function shows the parent function being shifted to have a vertex of negative 5, negative 6? So I could plug each of my calculator in my calculator and see which one's at -5, -6. Or I could know I had over. If it's inside, it's the opposite. So instead of -5, we need a +5. Outside of the parentheses is exactly the same, so -6. So x plus 5 squared, no, no. Ah, there it is. And let's check that one. So we've got y equals parentheses x plus 5 squared minus 6. Does that look like it's at -5, -6? Yes, we could check on the table. Pairs, pairs, yes, -5, -6 is right there in the middle. All right, if the following graph was shifted left 4 units, okay, so I know that that would be x plus 4 in parentheses, where would be the new vertex? Oh, it's giving me a graph. I just have to count. So here's my original, and I'm going left 4. 1, 2, 3, 4. So the new vertex is at -2, -2. Easy as pie. That saying never really made sense to me. How can you be easy as pie? Pie's not easy. Have you ever made a pie? It actually has a lot of steps. All right. The graph below shows h, the height in meters of a model rocket, versus t, the time in seconds after the rocket is launched. From the graph, what conclusion can be made about the flight of the rocket? All right, the height of the rocket was 12 meters at 3 seconds. So 3 seconds. meters. 10, 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Looks closer to 13, maybe. All right, the height of the rocket was 0 when it was launched. No, when it was launched, it was right there at 2. That one's not it. The rocket reached its maximum height after 1.5 seconds. No, I'd say its maximum height's at 2 seconds. The height of the rocket was less than 16 meters after 2 seconds. So 2 seconds, was it always less than 16? Yes, that one is the true one. All right, how is the graph shifted from the equation? All right, so I'm going to compare this to this. So let's put this equation in. Where would the vertex be of this equation? So the opposite of this is 2. Keep that the same, minus 5. So the vertex is at 2, -5. So this is what the equation is. So how is the graph, so how is this shifted from this? Let me just check to make sure that looks correct. 1/2 parentheses x minus 2 squared. So if I look at it, the vertex should be at, I said 2, -5. So -3, -3, right there at 2, -5, yes. Okay, so 2, -5, that's my vertex. So how is the graph shifted from this equation? So from here, it is going up 1, 2, 3, 4. Up. Did I count that wrong? Two, 1, 2, 3, 4. Ah, I did. This is -5. My bad. I wrote it down. I just didn't graph it correctly. So to get from here to here, I'm going up 1, 2, 3. Up 3. There's your answer. Which equation would appear to be shifted 6 units up from this function? So to go up 6, you're going to add 6 on the outside because I had over. We want a vertical shift, so it's on the outside of the parentheses. So we are going to add 6 to this number. So we'd get x squared. 6 minus 2 is a positive 4. D is your answer. Match the description to its equation. Moves right 7. Okay, I hot over. Right is a horizontal change. I'm going to be dealing with this. So I know it needs to be inside the parentheses, so it's not this one or this one. And it's the opposite of what I would think. So to make it go right, I actually need to subtract. So the answer is D. We could check it. Parentheses x minus 7 squared. From the vertex, did that go right? Yes, it did. All right, Sydney multiplies the coefficient. Ooh, what is a coefficient? Co-worker to x. So it's that number in front of x. So this number right here. So she multiplies this by 1/2. So your new equation, half of 4 is 2x squared plus 2. Let's compare it. We've got 4x squared plus 2, and now we've got 2x squared plus 2. Let's see what happened. So there was the original, there's the new one. So it got wider. So that is a vertical compression, which is the same thing as a horizontal stretch. That is your answer. All right, members of the math club launched a model rocket from ground level with an initial velocity of 96 feet per second. This can be modeled by this function. Find h of x equals 80. Okay, the 80 is outside of parentheses, so that's the y value. So I'm going to go on the y to 80. And where does it hit? It hits right here at 1, and it hits here at 5. Right there. Notice, guys, they're trying to trick you. They have one that only has 1 and one that only has 5. It's 1 and 5. So check all the way across. 23. Members of the math club launched a, so it's the same thing, okay? What does the point 580 represent? So 580, what does that represent? So the x is seconds, so this is 5 seconds. The y is height in feet, okay? So the ball dropped 80 feet in 5 seconds. Okay, so that does have 80 feet in seconds, but it's not dropping that far. No. The height of the ball was at 5 feet. No, it's 5 seconds. The ball was in the air for 5 seconds. No, if you follow it all the way around, the ball was in the air for 6 seconds. The ball returned to a height of 80 feet. 80 feet, 5 seconds. Is it returning to that height? Is it going up and coming back down to 80 at that point? Yes, it is. What is the Y-intercept? So where it crosses this Y-axis right here. So I've got to know it's at 2. So is that point, so it's not this or this, is it 2, 0 or is it 0, 2? A Y-intercept has the Y value. It is 0, 2. What is the slope of the equation? To be able to find the slope, I have to first solve for y. Isolate other side, so minus 5x. You write them side by side. Divide everything by negative 6. So y equals 12 divided by negative 6 is a negative 2. Negative and a negative is a positive 5, 6x. Okay, slope is the part in front of x, so right here. So it's a positive 5, 6. That is your answer. All right, what is the range of the function? Okay, so if I'm finding range, robot, range is bottom to top. The bottom, I don't know where it's at. That has arrows. That is not the bottom. The top is right here at 3. So we know it's going to be something 3. So it's not this. It's not this. All right, so is it all real numbers greater than 3 or is it less than 3? It is less than that 3. your y values are always less than or equal to that 3. The quadratic equation that can produce this table is what? Well, I'm going to look to see where my vertex is. 0, 4 is my vertex because here's a pair, here's a pair. So I know that it can't be this negative 4 right here. So let's see which one of these equations match. 4x squared plus 4. So -2, -12. Nope. Let's try the next one. -4x squared plus 4. -2, -12, -1, 0, 0, 4, 1, 0, 3, 2, -12. Fantastic. Last question. You're trying to throw a ball over a wire that's 40 feet above the ground. So your wall is 40 feet above the ground. The height of the ball is modeled by this equation. What statement best describes the situation? The ball was initially dropped from a height of 35. No, it wasn't dropped. It was thrown from way down here. The height of the ball increases until it reaches about 35. Increases until it reaches about 35. That could be it. The time depends on the height. It's y, or the dependent variable. Remember, Dr. XY needs his ID. Dependent is y. So not time's not depending. Time doesn't depend on anything. No. The ball was in the air for about 5 seconds. No, it was in the air for 3 seconds. So that is your answer. All right, make sure you have everything written down. And you will turn this in on the day of your test. Have a good day.